Lead comedy, each one of them, some sports drama. Wednesday is an early out. 1 o'clock early release, white day schedule. Reminder then you have block 1 through 3 prior to lunch. You have lunch and then you all come back for white block 4. That's Wednesday is an early out. Find on Bull Walton, today is the day you start practice. If you talk to Mr. Nida, not too late to do so. Practice starts today for anyone interested in pole vault. That's not, winter sport. Seniors, you're eligible to give the graduation speech. Received an email this morning. Please read that and respond accordingly. Either see me if you're interested or reply back to the email and get you on the list. So all please stand for the pledge. To the flag. All have a great day. Great.
Not quite half the class out, but to be expected. Remember, construct and label. And label. That means make sure you have your 5-number summary on there, actually labeled by point. Make sure that your box and whisker plot is proportional. Don't just make a generic one and then throw numbers on it. Like if one part of it is bigger or smaller than another, make sure your graph reflects that. Double check your numbers. You don't want things thrown off by just mistyping something. And then when you are done, Michelle is furious. Our central copier is indeed dead. You can go grab the first few pages of the Chapter 1 packet and staple or hole punch as you see fit. We'll just keep adding on to it. It'll be like the math packet of Theseus. You good? I ain't marking anyone late today. I understand. For anyone using the in-class calculators, reminder, those get used 2-3 blocks a day fairly consistently, but the batteries in them last forever. So once I get about 4 or 5 of them that are all blinking red, your batteries are running low, then I'll charge them. Don't worry about it. When you get the battery's low warning light on them, they still last another week. Okay, box and whisker plot measures the central tendency and spread. That's that first page of 08 where we went through the different measures of center and spread. And again, when you are done, grab the first few pages of the Chapter 1 packet, staple or hole punch as you see fit. Copier is busted, so we're just going to have to add on a few pages at a time. Or if I get some time during my prep today, maybe I'll just hand sort the whole lot of them. We'll run the little copiers ragged. Remember, not just the box and whisker plot, state the measures of central tendency and spread.
That sucks.
Should be, I think, 4 back-to-back pages. Just go 1-1 through 1-1. Yeah. Yeah, if y'all know Miss Olson in the activities office, she's usually the one tasked with fixing those copiers, and boy, is she livid right now. She was gone on Friday, and someone did something they weren't supposed to, never fixed it, and then just walked away, so the thing overheated, and now there might be melted parts in it. Maybe. I shy away from paper clips because they scratch on the paper, and that sound and feeling just drives me nuts. But occasionally, someone leaves one in my room. There you go. Okay, everyone there? Or almost there, finishing up, and I can start pressing buttons? Okay. So, we went through it enough times. How do I enter data into my calculatron? Poke. Mutter, mutter. Stat edit. Stat, edit, stuff, type them in, hope you do it right. Double check my numbers, make sure, okay, fat finger syndrome, especially the emulator doesn't like anything on the bottom rows. So I usually miss zeros entirely. Cool. All right. So if I want a box and whisker plot and my measures of center and spread, where are those particular bits of information found? Stat calculate. Remember, there's calculate in two spots. There's calculate up here in the top row. The top row is all about the graph. So I can calculate stuff on my graph, but if I stat calculate, I will calculate things with my input data data points. So I'll go one variable stats, list one's where my data is. What do I put for frequency list? You ignore it, right? We don't have that much data. Calculate. Boop. So you are going to write down what are the three measures of center that we talked about. Mean, median, mode. Mean, median, mode. The ones you've been dealing with since middle school, maybe even elementary. Mean, X bar, 399.4. Okay, my median will be down here in my 5-number summary. We'll get to that in a minute. Mode. I would go to my list, and you just look for what happens the most, and nothing is ever repeated. So I'd say there isn't one. My measures of center are here. Spread. What are those? There were 3 that were discussed, but we said one of them we're just going to toss out. How do I tell how spread out my data is? Range, standard deviation. Okay. We have the entire population of our data, so we're going to use this guy. Usually you're just going to use sigma. So I'm going to say my standard deviation is about 23.892, and my range, well, I'm going to get that from my box and whisker plot because we said we never have to do that by hand again. Second stat plot. Plot one on. Make sure that it's a box and whisker plot. Make sure it's a correct list. We talked about the difference between these, regular box and whisker plot versus shorten it up so I know where my outliers are. It'll put a little dot or an asterisk out where the outliers are. If I just hit normal graph, okay, a normal 10 by 10 grid, I'm not going to see anything. So how do I see it? Okay, that's my cheater option, right? Zoom stat. I can manually change my window, and my data was all up at like 300 something to 400 something. I can manually change my window to see it like that, or once your stat plots are on, easiest way to do it is just zoom stat. So you should have this box and whisker plot on your paper. You should have something that looks relatively proportional to this, where the first quartile is short and the second or the fourth quartile is long. I'm going to trace to find my stuff. You should have minimum 369 labeled. You should have quartile 1, 381 labeled. You should have your median 395 labeled, which also goes here. Quartile 3 and quartile 4, or maximum at 454. So my range comes from that as well. 454 is the max. Subtract your minimum at 369. What's that? 3154.85. Y'all check my mental math. I've been up since 4. Okay. So we're going to say the mean, mode, standard deviation, and median. All of those come from just read it off the table. I'm going to leave one more for you got the range, and I had a fat finger moment and just oops one of the data points. Then we're going to say one for your box and whisker plot looks proportional. One for you have everything labeled by category, labeled by number. So 3 for the box and whisker plot, 2 for the stats written out. And it was mostly monkey button pushing. I mean, stats themselves are not usually difficult. They're tedious. It takes forever to hard crunch this stuff. That's why we use tools like Calculator to do it for us. And then it's a matter of how do I interpret that? What does it mean? I talked a little bit in here, right, about what classes you were going to choose for registration and said every single degree, if you want a 4-year bachelor's degree in anything, the minimum is college algebra, college stats. And the stats class, I can tell you right now, it's going to be boring unless you're just really into number crunching. But it's the interpretation of it is what matters. That's how you get informed citizens. You know, people who can look at a chart and say, "Are you kidding me?" There's a pretty bad example from I think it was early last week, where the what was it, the St. Louis Treasury or Federal Reserves, one of the big financials out of St. Louis, posted this ridiculous chart that was like military spending by country. And it's meant to say, look, China's spending more money. We need to be afraid of them. But it literally had a different axis on the right and the left. The one on this side was for every other country in the world. The one on this side was just for the United States. And literally this one didn't even start until past this side was done. And it went by a higher increment. And numbers don't lie. People lie with numbers. And taking a class like college stats is how you become an informed person. It's how you can look at that and be like, dude, that's like algebra 1. I know that I'm supposed to have a reasonable scale for my graph. What the is this? Okay? You need to know that. That's all I wanted to get out of the stats unit. Make sure that we remembered some stuff. I said the assignment was just get practice with finding that stuff from any set of data you wanted. If you needed the practice, basically, you could have picked anything. You could have picked number of fumbles per game by the San Diego Chargers. And that could have been your data that you collected. It could have been the shoe size of the 12 people that are in your house. Like, whatever. Just if you needed practice, pick some data points, make sure that you can press the buttons and you know how to create all the graphs. We barely got to talk about the whole standard deviation thing. Again, it's far more relevant than box and whisker. If you are going to go take your college algebra, college stats eventually, standard deviation is where it's at. If you're headed into any field that involves statistics, which includes education, medical, anything STEM, then I can run you through a little bit more of that on the side. It is not difficult. But yeah, it's just supposed to be warm up. Into one, everyone got their stuff, such that it is. Okay. If I got time, next hour is my prep. I'll see if I can run off the rest of the packets, and then you'll just sandwich them together and staple it from there. So, start with, we had to do this on day 0. Do we remember? That's the terrifying part. In the beginning, there was blurry double N. What are those called? Naturals. You know what? Let's actually get our color code on here. Natural numbers, Alabama math. Fingers and toes. Okay, it's everything. They're called counting numbers. 1, 2, 3, 4, 5, all the way up. Then we got into whole numbers. What was the only difference? Whole numbers just add in a 0. Then it started getting interesting. We would add in negatives, and they'd be integers. So positive and negative whole numbers. And then the big difference that we worked with was rationals versus irrationals. Rationals can be written as a fraction. Notice they have 0.6666666. We know that one because it was drilled into us in elementary school. Do you remember the trick for the repeating decimals now? What if I got 0.54545454545454? What is that? It's just a bunch of muttering. Come on now. Loud and proud if you know what it is. Something over 99, right? The repeating part over that many digits of 9. When you get a mixture, then you do a mixture of place value, then plus that. So like if it was 0.1, 23232323, then you do the 1/10 plus, and then it'd be 23 over 999. You just kind of mishmash the two ideas. But repeating and terminating decimals are rationals. They can be written as fractions. If they can't be written as a fraction, well, if they're not rational, then they are irrational. And every one of those is considered to be a real number. The reason we have to know the number sets is because sometimes we have to define domain and range and all that kind of stuff based on number sets. For example, the domain of most functions that you have seen is going to be in the real number set. So I can just use interval notation, which we're going to review in a minute. But some functions, like say the tangent function, they have infinitely many asymptotes in them, infinitely many gaps in the domain. So now I have to use set builder notation to tell you what the domain is. So we got to know what all this stuff is before we can even start describing things. Set builder notation, y'all remember it? You're going to say whatever your terms or elements are, values, there we go, your value, you put a big honking vertical line in there, a U, that's an E, I swear. Then you're going to have a rule of some kind, and then you're going to have the set that it belongs to. That rule often as not is just going to be an inequality because we're usually going to talk about real numbers. If we're in the real number set, we can just say everything that is less than 5. But that's usually how they're written. You'll say all x's, this means such that. They're going to use that element symbol again. Remember, this is element of. That's why we started. Our very first thing was with sets. So I'd say all x's such that my x's are less than or equal to 3, but greater than or equal to -3, less than or equal to 16, where those x's are elements of the integers. Okay, so set builder, I build what my conditions are for my values. And most of us are coming out of Algebra 2 from last semester, so you should have done that and interval notation. Most of us. Describe them using set builder notation. Uh-oh. That's right. Come on, Frank. There you go. You all see nothing. That doesn't exist. Or is that on your notes too? Crap. Okay, whenever I make my notes, I always just literally screenshot it out in the book. And then I put like a blank box over the parts that are filled in so that we can go through it together. Y'all know that if the answer is already there, you ain't paying attention. So I white box blank out the spots. Well, apparently, instead of blanking this, I blanked that. Oops. So, see that A has, wow, these are all messed up. This must have been an old PDF and I just forgot to fix it. Well, crap. You want to be as explicit as possible, as specific as possible. So for this one, I would say all x's such that. Give me a rule. Now, I know that they say on here greater than or equal to 8. Could I use something else and still be correct? I say 8, 9, 10, 11, then I got the ellipsis to say this goes forever. I could say x is greater than or equal to 8, or I could say x is greater than 7. Either one of those would work. What number set am I in if I'm being as specific as possible? I heard a couple mutter it. Naturals. Why don't I want to say whole numbers? Okay, there's no 0. So if I want to be as specific as possible, all right, Owen walks in the morning, I'm not going to say, good morning, mammal. Technically, that's in the kingdom, phylum, order, family, genus, species. Like, yes, unless you're a cyborg or something like that. Like, that's not specific, right? You want to be as specific as possible, so you'd say X is an element of the naturals because that is as specific as you can get. Now, I know that the words are already there. It tells us what we should be using, greater than or equal to 8. Why should I use that and not the greater than 7? It is a little more specific, because if I say greater than 7, don't you got to kind of think for a second, like, but not 7? Right? It might be a little confusing. That's not wrong. It is technically not wrong. But if I can be a little more specific, that's why I'm going to go with greater than or equal to 8. If they give me just a straight up inequality, say they just say x is greater than 16. Like, that's it. They just gave me an inequality. If they give me an inequality, they gave me the rule. If they gave me the rule, then set builder notation gets pretty easy. I just say all x's such that x is greater than 16. And then they spoil it for us because I blanked the wrong spot. To be as specific as possible, we usually want to narrow it down. On number one, we said we want all natural numbers. But can you name a number bigger than 16 that's not a natural number? 16.1. Okay, now we're in the rationals. Can you name an irrational number bigger than 16? There you go. Square root of 470. You know what? Put up or shut up. Can that be reduced? Okay. So you gotta be safe, right? Start going. No, 471 is not one of my perfect squares. So because I can name rational and irrational numbers bigger than 16, whenever you have an inequality, you assume the real number set. Okay? You should assume the real number set unless they give you specifics like part A. Multiples. Multiples are iffy. That would be a number set like -6, -3, 0, 3, 6, like that. Okay. And you'd say those are all multiples of 3. To write it, I was hoping we could try to wiggle our way through it, but it's already written for us. The cheater way to write this is I have to say all x's such that my numbers, the x's I'm talking about, are going to be something times n. So in this case, 3, because I'm looking at multiples of 3. So if I had multiples of 5 on there, it'd be x equals 5n. But what do I have to multiply it by to make sure it's always a multiple of 3? Like, can I take, it's 3, 6, 9, 12, 15, 18, can I take 3 times 1? Can I take 3 times -5? Yeah, it's still a multiple of 3. But as soon as I say 3 times 1/2, now it's not a multiple of 3 anymore. So to ensure that I'm always taking 3 times a thing and getting a multiple of 3, I don't say x is an element of, I say that I will multiply it by an integer. And they're always going to take that form. Fun part of that, I can even do that with things that themselves are not integers. I could say multiples of e. Like if I had a set, like, I don't know, 5e, 6e, 7e, ... then I could still say my x's are e times an integer. And that would still make sure they're all multiples of e. It still works. Okay. So there's different ways that these come out. And now, no cheating for you, ABC. Write those out in set builder. All x's such that, rule, semicolon, what set am I belonging to? Remember, be as specific as you can. And if you can't be specific, you assume real. Okay, should be pretty fast. All x's such that my x's are greater than or equal to 1, but specifically, where do they reside? X is an element of who? Natural. Again, I don't want to go all the way down to whole because whole has 0. Be more specific. Okay, all x's such that if they give me an inequality, they gave me the rule. Just copy the rule. But then, where do I exist? What number set? Reals. Because I can name both rational and irrational numbers less than -3. So, I'm going to say all x's element of the reals. And, kind of spoiled it. Yeah, I can do multiples of pi. It's all x's such that x is pi times n. -18 pi is a multiple of pi. 312 pi is a multiple of pi. So I say I'm going to keep multiplying by n is an integer. And again, those squiggle brackets, as long as it's kind of squiggly and doesn't look like a 3, you don't have to be an artist. For some reason, kids get hung up on their brackets and whether they look good or not. Okay. Yes. In fact, everything about this is always going to be the same when they say multiples of. The only difference is that. Like that format is always the same when they say multiples of. It's just whatever your multiples of are, that goes in front of n. Every time. So for example, in that tangent function I was talking about, there's an asymptote at pi over 2, and then another asymptote every pi away from that. So I would say that I have infinite number of asymptotes at pi over 2 plus pi n, so I'm dealing with multiples of it, where n is an integer. And it happens infinitely amount of time. What if I get a compound inequality? Look at 2 and 4 downstairs. How do I write that? Say that louder. Yeah, your compound inequality is your inequality, right? That is the rule. You can have an and sandwich or the word or in your inequality. Y'all learned that in algebra half. Okay, so if I wanted this as a if I wanted that as a set, it would just be all x's such that this x element of the reals. Like that is my rule. Okay. Now, as I know the majority of you did interval notation in Algebra 2 because we see element of the real so often. Our graphs usually cover everything in between, every real number that we can think of. So we shorthand it. Okay, we got a cute little chart here to give you different examples. But the short version is parenthesis, your lower boundary, your upper boundary, where this does not equal and this equals. Parentheses, can't touch this. Brackets, can touch this. Okay, whether it's on or off limits. So look over at the examples of unbounded intervals. Say, for example, it's x is greater than or equal to 5. Well, my lowest boundary is a 5, but if I say greater than or equal to, where do I stop? Infinity. Now, it's or equal to, so we can equal 5. I put a bracket. How come all of these have parentheses? Can't touch infinity. Infinity is an idea. Okay, starting to cross math with philosophy here, getting into the metaphysical realms. But the most relevant example of that I can think of for kids is you have all been a part of the argument on the playground that says, you know, yeah, well, I've got my force field dog. Well, I've got my dinosaur that eats force field dogs. Yeah, well, I've got shields times 1,000. Yeah, well, I've got nukes times 1,000,000. Yeah, well, I've got shields times like infinity. And then what comes after infinity? Infinity plus 1. Infinity times 8. Infinity times infinity. And then you get the one kid who's way too smart for their grade level that says infinity to the infinity power. And then you get the infinity factorial of infinity. And then you start getting into inception, basically. Whatever you think is the end of the road, infinity is an idea. You can't actually touch that. You're going to keep going afterwards. Okay? So we will always put parentheses on infinity, both positive and negative. You know, the old my dad can beat up your dad kind of arguments. God, those are so, kids are dumb. Write each of these numbers using interval notation. When I have and sandwich like this, I have my lower and upper boundaries. I write it like a coordinate, not equal to this, parenthesis, equal to this, bracket. When I have an unbounded one, the highest it ever goes is 11. If it's everything less than that, treat it like negative infinity as the other part of the coordinate. Can't touch infinity, can't equal 11, so it's going to look like a coordinate. We just got to know that that's an interval instead. Do y'all remember how to write C? Union. And that's why the first thing that we do in PreCalc is review sets. Literally, or is the union of the math world. So I'll say negative infinity to negative 16 union everything from 5 and up. 5 to infinity. And that's also how we start excluding things when we talk about domain. Yeah. Can it equal 5? If I say x is greater than 5, that would be like saying, Lori, how tall are you? How do you not know how tall you are? Just the general example is, are you taller than yourself? No. Are you older than yourself? No. Okay, so it's not x is greater than or equal to 5, so I don't put a bracket because it can't equal 5. Now, it's as close to 5 as you can get. It's 5.00001. You know, the talking about annoying kids. I'm not touching you. I'm not touching you. I'm not touching you. It's the kid right there, but they're not touching you. Okay. Oh, everyone knows that kid gets hit no matter what. Like, we're mammals. We got those little short hairs everywhere on our body. They get that close and you can feel it, right? And you punch them anyway. So, ABC. Write them as intervals. Lower boundary, upper boundary. If you got multiple, you need a union. want you to think real hard on 2C about how you write it, though. Or more appropriately, the order you write it. Man, y'all creepy quiet this morning. Contestant 1, they gave me the boundaries. We just have to decide bracket or parenthesis. -4, bracket or parenthesis. Or equal to -1. Not equal to. -3 is at the upper or lower boundary. Lower, okay. Come on now. It's a lower boundary because it's everything bigger than that. So I go from there to infinity, and we say we can equal -3. We cannot touch infinity. At least not without a large amount of psychedelics. 2C, I mean, if you want to transcend the physical realm, you just eat mushrooms like Mario told you, right? Seriously, you know that the person who came up with Mario was on shrooms. Eat mushrooms and you grow big and strong. And you start flashing colors. Okay. Now I'm betting most of us have this as 9 to infinity. I'm betting most of us have -infinity to -2. And I'm betting we got a union. Why is that wrong? It's supposed to be written out like a number line, where I want like this, because now doesn't that read like a number line from -infinity to infinity? Think of the x-axis. Okay, now that's important because we're about to start talking about domain, where if we're describing the domain, it doesn't make sense to keep backing up and talking about something back here and then come over here. Like, who else gets confused when you have the movies or the books that always hop back and forth in time? Like, this is what's happening now. Flashback! This is what's happening now. No, this is going to happen 10 years from now. This is what's happening now. Just, I don't like it. Don't like it. Okay, you want that thing to run chronologically. Okay, basic definition. Words are hard. Basic definition of a function. What is it? Yes, I know you can read that. In your words, what is a function? How do I know something's a function? What's the difference from a function to a relation? I went on so many rants about this in my class. So those of you that just came out of my room, Papa Bear disappointed. Okay. All right. Here we go. A relation is a rule that maps input to output. Called domain and range. A relation is any rule that maps input to output. Okay, for example, if I said the sister relation, and I threw one of you into that particular relation, is there someone in here who's got more than one sister? Okay. So it would spit out more than one output. It is still your relation to them, right? It's what defines the relation from input to output. A function is a specific kind of relation where each element of the domain goes to exactly one element of the range. Easiest way I can think of that is a functional machine. Assuming I'm paying for things, I press the Mountain Dew button on the pop machine. I get a Mountain Dew. I press the exact same button on the machine. What should happen if it's a functional machine? Okay. But if I press the button again and it spits out like cream soda, that is A, disgusting, B, not a functional machine. I'll fight you on that one. If I, okay, ice on the roads, this morning as you're driving to school, you lay on the button in the middle of your steering wheel. It lets the person in front of you know that they're supposed to rethink their life choices. I press that same button again and my windshield wipers start going. It's not a functional machine because the same input had two different outputs. I press the button, my volume goes up on the TV. I press the button again and it just turns off. It's not functional. Okay? Input, the button you press. Output, what it does. Okay? Anyone who has ever played video games has screamed at their controller, that's not what I said. Like, reload! It's not doing what I told it to. Okay? I didn't say squat down, I said run away. The examples of this that we see physically. Okay, you remember crossing the wires like this? They're called mapping diagrams. Kind of like playing Among Us, making sure that the trash goes out, right? This is currently a function. It's okay that these two are both going to 8. Can I have more than one of the same button on a pop machine? Are there more than one Dr. Pepper button on this pop machine? As long as they're doing what they're supposed to, it's fine. But what if I took this and flopped it around? Now I would press the 8 button, it says 2. I press the 8 button again, it says 3. It's not functional if I flop them around. So we see them by mapping. Remember good old vertical line test? Also called pencil test? The vertical line test says, I am pressing X equals C. I'm pressing this button. I only get one output. I'm pressing this button. You know what? I'm pressing this button. It only hits it once. I'm pressing this button. It only hits it once. I'm pressing this button. It only hits it once. Only hits it once. Only hits it once. That's a functional machine. It's doing what it's supposed to. But I hit the button. The microwave turns on. I hit the button. The door falls off. It's not a functional machine because that input had more than one output. Okay? So, examples of whether something is or is not a function. The input value X is a student's ID number. The output value is their score on a physics exam. So I put your ID number into Campus and, you know what, let's get rid of physics. Let's say PreCalc. I look up your ID number on Campus. Will I only get one output for score on PreCalc test? This is where you could start to argue, right? Where could you see yes or no? Where could it be I look up cadence and I only see one thing? I look up cadence, I see more than one thing. Okay. It depends on what do they mean by test. Do they mean on a specific test? Or do they mean on any test? So, like, right now, we've only taken one test. It would literally be yes. But as of later this week, Thursday, right? Yeah, Thursday, you take quiz number 2. Assuming that I actually get time to grade them, there will now be 2 of them in there. It depends whether I'm saying on exam 1 or on any exam. And if that's the case, I want you to argue. I want you to write next to it. You could have taken more than one test. Okay, so however you define it, this one could be yes or no. What about B? Yay or nay? Are you sure? I see -3 on there twice. But the input, the buttons I'm pressing, they are all doing one thing, so it's okay. In fact, when you get a parabola, we just spent how much time graphing? Doesn't the -4 button and the 4 button both have the same output? As long as that button is doing what it's supposed to, you're okay. So for A, I would yes or no and argue, whatever you thought. For B, I'd say yay. Yee. Actually, let's not do yay. Like, nah, dude, get out of here. And C, they even drew the line for you. That's a big fat old note burger. D, how do I know if something is a function or not just from an equation? Every input has one output. What represents input and output in a graph like this or a function like this? X's and Y's, domain and range, right? So how about you get Y by itself? Add to X. It's Y by itself. Then what? And I put the square root there. So when I put the square root there, don't I get plus or minus? So now, what happens when I plug in X is 2? Right? I press the 2 button, 2 different things happen. A +3 and a -3. So that one I got to say no. Do you remember all the way back to the beginnings of algebra doing this? Words, table, graph, equation. The 4 different ways to represent a function. So, let's see if y'all can argue with each other. A, B, C, D. Is it or is it not a functional machine? And not just yes or no, but if it's a no, tell me why. Who's the culprit? Why doesn't it work? It's like if I'm looking at the seating for a classroom and I look at a particular table right before a test, I'm like, no, that ain't gonna work. Who? Who ruined it? who was that? Look at last year. Trying to think of my goof troop from Algebra 2 last year. Algebra 2, open chart. All right, I want you to think of this, all four of them in the front row. Jacob Garnis, Caden Langenfield, Dawson Wood, Rylan Palmer. Wham, 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 wham. All in a row. And if any of you know those guys, I think they're all seniors now. Put any of them next to each other at a table, problem's going to happen. Especially Dawson. I thought he didn't have pants on one day. Like, his pants were actually around his ankles. Like, I had to do a double take. I look over in class and I'm like, dude, what? Because all I see is like knees and pants on the ground. He's wearing his little shorty shorts. He was just too hot, so he decided to just drop his pants. Like, but okay. Sometimes you look at something and it don't work. You tell me what doesn't work about it. The input value is the area code. Output is a phone number in that area code. Function or not function. Why or why not? Man, y'all have been conditioned to just be terrified of being incorrect. Y'all just say something. Worst case scenario, you learn something. I heard a yes. Do we have a no? Okay, so we got a yes and a no. Fight. Why? What's oh?
So like it's like this, and it goes to all these separate numbers. Okay, but there's still a number in that area code.
I input an area code. The output is a phone number in that area code. Y'all, 605. Uh huh. Is there only one phone number? Okay. Exactly. An area code is like the subheading. That would be like mammals. And then everything below it. Then you get the area prefix. Then you would get the specific numbers at the end. That's why they're all broken up as 334. Yeah.
But then like, so I'm from Wyoming.
Uh-huh.
307.
Uh-huh.
So wouldn't that come out right now because I'm like.
Is there only one phone number attached to 307? Okay. Now, sometimes if you look around in western South Dakota or Wyoming, it might look like that, but no. Like, you are inputting the area code and saying there's only one phone number. And that's just not true. Now, back up about 80 years and maybe, okay, y'all ever heard of party lines? Like, there would be one phone number, one phone line going to an area, and then it would junction out to all the houses in that area. So if someone called that phone number, every one of those houses rang. They would all pick up and be like, nah, it's for me. And then you'd talk to the person. The problem was, when you hear that little buzz in the background, that tells you that someone's still on the phone and they're listening. That's how that was like the original Facebook stalking. Is you would just answer every phone call and just never say anything. Okay? Like, that used to be a thing. 3B, yay or nay? Who's the culprit? 5. And if you were supposed to explain that, I would say something as simple as no, 5 maps to 8 and 9. You're showing me that it goes to 2 different places. I'm okay with that. 3C, yay or nay? It does. And you should remember this from Algebra 2. Even though this goes up very sharply, if I were to zoom in on this, it does show a curve like that. Okay, so it might look like it's almost straight up, but if you zoom way in on it, it does still have a curve to it, so it will pass vertical line test. Yee. What about D? Absolutely, it's just a line. Okay. So, just is something a function or not? That's a basic definition. That's like beginning of algebra half. Ooh, just tell me yes or no. Is that a function? It passes a vertical line test. Do you remember inverses from algebra 2? Inverses, you swap x and y. Would the inverse exist as a function? Does that infinitely fails the horizontal line test? Okay. All right. So we seem to be struggling more with the word part. So how about 5? Yes or no? Can I put in a car's license plate number and I will only get the make and model for a car? Unless there's illegal shenanigans afoot, right? Correct. What's South Dakota again? Is it number, 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 letter, letter, letter? Or the other way around, or is it mixed? It's mixed? Okay. I always do a vanity plate just so I can remember what it is, just because I'll forget all the time. So. All right. It's actually not that bad. Honestly, if you got really bad memory, the extra like $30 a year for the vanity plate, I'll do it. Okay, this one. I talk about this in my algebra 2, and kids are like, "Yep, that's what we were told," and it's wrong. Equation versus related function, function notation, on and on and on. Function notation. F of x is, and then I will give you some rule, and then you get y. You have been told at some point in your mathematical career that f of x is just a fancy y. That is wrong. Usually, it's a math teacher who's tired of trying to explain the difference to a group full of 8th graders or freshmen, so they just kind of give up and say it's a fancy y. What is this? It's a thumb, it's a finger, it's an opposable digit, phalange. Phalange is just fun to say, right? Button smasher, ant killer, okay? You can talk about the same thing in different contexts, right? Think about you and your identity with your friends versus your parents versus your grandparents. Okay? How many times does your friend walk up to you and say, "What's up, Mom?" Okay? maybe some people are gonna talk like that around you. Maybe you and your friends trash talk a little bit. Versus you go to your parents, they just call you whatever your name is. You go talk to grandma, and she's gonna call you moon pie or sweetie or whatever, right? So you can talk about the same thing in different contexts. What I want you to write next to this, it is overlooked in Algebra 1. We try to stress it in Algebra 2, and kids just don't care. I'm going to say it matters. F is the name of the function. This isn't f times x. It's the name with the input equals the expression that tells you what to do with the input that gets me my output. But you all know that from geometry that you can cut out the middleman. You remember the substitution and transitive properties? Like if A equals B and B equals C, cut out the middleman, A equals C, right? I had a kid years ago who was like, every Thursday is throat punch Thursday. And they looked over at their friend. Like, walked into class one day, I was like, it's Thursday. Just went over to my desk, and behind me I hear, okay, if it's Thursday, then it's throat punch Thursday. If it's throat punch Thursday, Kevin gets punched in the throat. All I had to say is, it's Thursday, and walk away, because transitive property says you can cut out the middleman and go straight over here. Don't punch people in the throat. It's not nice. Okay? Because f of x will get you a y, yes, you can replace one with the other. There is the transitive property that allows me to say I can replace f of x with y, but they are not the exact same thing because they're talking about it in different contexts. Okay? That is the difference between, I don't know, Holly's friend calling her Holly versus Holly's friend calling her Moon Pie, right? Like, now someone's just going to start calling you Moon Pie for the rest of the week. When we say the equation versus the related function, those are two different things. Okay. F of x is, 2x plus 1. Y equals 2x plus 1. They are not the exact same thing. Now, in terms of how we work with them, they're nearly identical, but they are not the exact same thing. It sounds like we're arguing semantics until you get into, do you remember doing rules with functions, operations, compositions, inverses? As soon as we start getting to higher math, like algebra 2 plus, the difference matters. Independent and dependent variables, kind of like when we were talking about our probability the other day, can you tell me the difference between independent and dependent variables without using the word depend? Okay. Someone breaks out their thesaurus and just says it relies on. Independent variable, y'all, it says it right there. Input. Input. Also my domain. 99% of the time, that's our x's. So my dependent variable is the output, also called range. 99% of the time, it's y. Okay. Think of it like who comes out of the building depends who went in. You're not just going to teleport into the school and then walk out, right? So down below, as we talk about this input business, find each function value. If I say g of 6, the purpose of g is to square a thing, add 8 times the thing, and subtract 24. Think of this like the name of the machine. This is the guts inside the machine and what it's doing. So if I say find g of 6, everywhere that there was an x, I put a 6. And then you evaluate with order of operations. 6 squared is 36. 8 by 6 is 48. 48 minus 24 is 24. 24 plus 36 is 60. I did mental math before lunch. I've been up since 4. Check me. Okay. That holds true no matter what I want to put in the machine. If I said g of a thing, I'm always squaring the thing, adding 8 times the thing, subtracting 24. So I can now put in an entire negative 4x. What I get out of the machine might not be a concrete value, but it will be an expression that I can simplify. Next to this, maybe your big neon highlighted, watch out for this note. Y'all use parentheses. When you are inputting things, please use parentheses. Parentheses keep us from screwing up negatives and exponents. Because how many of us are going to goof and call this a negative 16x squared? Okay, I hope not. That's freshman math. But when I square a negative 4x, it's positive 16x squared minus 32x minus 24. Someone usually asks, they say, wait, can I take out an 8 and call that 2x squared minus 4x minus 3? Green versus yellow, which one is simplified? Okay. Green one is simplified. When you have parentheses, it implies there is an operation still to be performed. Okay? This is like regular mac and cheese versus easy mac. Some assembly required versus just water. Okay? Well, I suppose water is still some assembly required. Okay? X squared 8x minus 24. Even if it gets bigger, g of a thing is the thing squared minus 8 times the thing minus 24. That was plus, wasn't it? Plus 8? Yeah. Okay. If I say g of this entire expression, I do mean throw that entire 5c plus 4 in there. And when you simplify this expression, again, do not square like a freshman. I swear to God, if you just photomath that.
No, I didn't.
Slater? You got to be able to do it for real. Make sure that you square the entire thing. Do not just say 25c squared plus 16. Okay, that's freshman math. There's a whole middle term in there. If you need to write out 5c plus 4 times 5c plus 4, and if you want to use any app to confirm that, you go right ahead. I know, especially our history and English classes, our teachers are absolutely losing their skittles right now because of the AI. Was a chat GPT, CPT. Like I've been following that with actual educational professionals around the country, and the AI is passing like grad level exams at universities. Okay. The problem is what happens when you say that and then you say you're this good in high school, you go to college and they want you to do an oral exam, you have no idea what's going on. You lose your scholarship because you failed the class. What happens when you do that in college, it makes it look like you're really good. You get this degree, you go get a job with a certain person says, okay, I want you to give a presentation to these folks, and they're like, okay, but what about this? You get fired because you have no idea what's going on. You can't perform at the level you said you could. So it's a tool to be used, yes, but you still have to do it. All right? Math teachers, we've been fighting with this for probably 10 years now. Friggin' Slater. Okay. Slater Math App and PhotoMath. We've been fighting with that for years. That's why I also don't have homework as part of our grade other than completion. It doesn't tell me what you know. Now, that quiz right in front of me when your phone's over here, that tells me what you know. Most of the time. So, if you want to check, go ahead. Y'all, I told you, I ain't the phone nanny. I want you to use your resources. If you need to do that to check things, fine, I don't care. We are going to hit a level in here where it ain't going to do it for you. But please make sure you square this correctly. That's 25c squared plus 16. Does anyone remember the trick for this? Squaring a binomial? We try showing you in Algebra 1, and everyone says, screw it, I'll just FOIL. Square the first term, square the second term, and then aren't you going to have 5c times 4, 4 times 5c? You're going to have 2 of that term, so your middle term is just multiply and double, because you'll have 2 of that term. If you understand that, then you will do this faster than it could be to copy something down. Then I've got 40c plus 32 minus 24. Combine like terms. If you need to go all the way back to algebra half for that, there's nothing wrong with every time you run into a plus or minus, it's a new term. And then sort your Legos. Any of those that go together. I've got this many c squareds. 40 c's and 40 c's is 80 c's. 16 and 32 is 48. 48 minus 24 is 24. Okay, so it is expected if you came out of Algebra 2, you should be able to, how did I? Because way back here, this is 5c plus 4 times, 5c plus 4. Okay, don't forget the middle term. Don't square like a freshman. You hear that phrase an awful lot all semester long. Don't square like a freshman. Okay. Can you do it with a rational function? Go. 4ABC. Can you do it with a rational function? So for 18 bucks, that thing will almost do your taxes. Actually, if you program in the algorithm, you can. What's the standard deduction right now is like 7,500 or 9,500. If you make under that, you just claim 0 exempt and hand it in and get it all back anyway. I mean, unless you got some kind of farmhand or mafia job where you're actually making money. So when I was in high school, I got paid with an awful lot of checks from farmers that were written in the memo parts expense. And be careful. Use parentheses. Don't square like a freshman. 12, 144, 224, 120, 121, 12, 24, 3, 27, 20, 21. 5, 3, 8, 3, 5. That's negative 6, 8, 2, 8, 16 plus 9, 4, 9, 8 squared. It's negative 24, negative 48. Negative 48 plus 6, negative 42, 8 plus 64, 64 minus 16 is 48, 48 plus. Check me before I wreck me. Because this is all I do. It's this, play with nerd games and parent goblins. Like this is my thing. It's been a while since I've tried. Will the 36s do 4C? I don't even think they would do 4B because X would be a value stored in the calculator.
Yeah, they give you they give you 3. That's what it pops out.
Okay, so it's using whatever the most recent stored value for X is and literally putting in 6 times number into the function. So, won't do everything for you, but it'll do a lot.
Yeah, and then it gives you 19 over 49 for the last one.
Yeah.
So it doesn't go all the way.
That's if you hit the ABC XY number, it'll cycle through. If you use that with when you do regression models, it'll store the coefficients so that you can then come back and just poke.
Yeah.
It's pretty nice.
To do this, you have to like figure all variables, and then it'll spit out 19 over 49. Otherwise, it comes up with some really.
So it's treating them as zeros.
Yeah.
Okay. I don't hear anyone correcting me on them yet. So either we're getting the same thing or we're still skittish. Y'all get them brownie points. Good. Particularly, there is something I want you to be careful about. Look at 4B. What if I got this? You make sure when you evaluate a thing, make sure that your final answer can't be simplified. Additionally, what happens if that was 12x plus 3, 3, 5, 3, 4x plus 1, 4, 4x plus 1, 36, 9x plus 1, 4, 9, 36, 72 plus 72x plus 1. If I had something like that, there is a chance that you could factor things. Y'all remember rational functions where you get x minus c over x minus c? There will be times where you go to evaluate and you can take out an entire binomial. You have to check that. Now, in this case, it didn't happen for any of them. But you do have to be aware of that you might be able to eliminate something. Okay? C and B are just placeholders. So, that's about right. Yeah. So, tomorrow we just finish 1A, move into Section 2. I hope I have the rest of the Chapter 1 packet for you. Depends whether the little copier fights me or not. So,
Oh, remember the quizzes are open notes, but after our quiz,